is Jo Karen Hudson. In this video, we're going to talk about rational expressions and functions. Let's first start with the division property of 0. For any real number a, such that a is not equal to 0, 0 divided by a is 0. That's like 0 divided by 5 is 0 because 0 times 5 is 0. And a divided by 0 is called undefined. Remember, we cannot divide by 0. 5 divided by 0, there is nothing we can multiply times 0 and get 5. Division by 0 is said to be undefined. A rational expression is the quotient of two polynomials if the denominator of the rational expression is not equal to 0. We cannot use any value for the variable that causes the denominator to be equal to 0. Find all the numbers for which the rational expression is not defined. Find the domain of each rational expression. Write the domains in set notation and in interval notation. Now, how do we find the numbers that make the rational expression undefined? Well, we set the denominator equal to 0. X plus 3 is equal to 0. If I subtract 3 from both sides, you see I'll have x is equal to negative 3. Now, if I go back and plug in negative 3 into the denominator, negative 3 plus 3 is 0. Negative 3 is the number that makes the denominator 0. So when I express the domain as a set, I'm going to write x such that x is a real number and x is not equal to negative 3. Don't want it equal to negative 3 because that makes the denominator 0. If I express it as an interval, let's look at a little graph of it. You have a number line and you're leaving out negative 3. So you're having everything on one side of negative 3 and everything on the other side of negative 3. Now we're used to putting a parenthesis when a point is not included. This is negative infinity over here. This is positive infinity over here. So written as an interval, we have what's on the left of negative 3, which would be negative infinity to negative 3, and we have what's on the right of negative 3, which would be negative 3 to positive infinity, written as an interval. This is the set builder notation. This is the interval notation. Example 2. I want to set the denominator equal to 0. X squared minus 2x is equal to 0. I'll have to factor that to solve it for x. If I factor out an x, I'll have x minus 2. And then if I set the x equal to 0 and the x minus 2 equal to 0, there's my first solution. Add 2, x will equal to 2. Now these are the 2 points that cannot be in the domain. Those points cannot be in the domain. If I write it as a set, I'll write x such that x is a real number and x is not equal to 0 or 2. If I write it as an interval, let's see, let's look at it in a number line. We're omitting 0 and we're omitting 2. So this actually breaks the graph into 3 different regions. The part over here that is to the left of 0, negative infinity on this side, the part that's between 0 and 2, and the part over here that's greater than 0 and goes to positive infinity. So let's get the 3 different regions. This region from here to here is from negative infinity to 0. From negative infinity to 0. Union, the second region is that region that is between 0 and 2. And the third region is that region that's on the right of 2. It is from 2 to infinity. This is the set notation. This is the interval notation. Continuing on, I have to set the denominator equal to 0, x squared plus 10x plus 21 is equal to 0. So I'll have to factor that. Let's see. This would be the product of 1 and 21 would be 21. So I'll have 1 times 21 or 3 times 7. But I'm looking for the pair that adds up to 10x. So I'm going to rewrite this as x squared plus 3x plus 7x plus 21 is equal to 0. And then I'll be able to factor it by grouping. Take out an x, I'll have x plus 3. Take out a 7, and again I'll have an x plus 3 because 7 times x is 7x, and 7 times 3 is 21. When I take out the x plus 3 out of both of them, I will have x plus 7 left. So if I set x plus 3 equal to 0 and x plus 7 equal to 0, I'll have x is equal to negative 3 and x is equal to negative 7. So as a set, I'll have x such that x is a real number and x is not equal to negative 3 or negative 7. If I write it as an interval, remember as an interval, negative 7 will go on the left and negative 3 will go on the right, and this will divide it into 3 regions. The part over here that goes to negative infinity, the part over here that goes to positive infinity, this part which goes to negative infinity, this part that goes to positive infinity, and the area in between. So looking at it as an interval, this part right here will be from negative infinity to negative 7. Union, I'll have the part that's between negative 7 and negative 3, which is right in here. And then I'll have the part that is from negative 3 to positive infinity, this part right here. So I have expressed it in set notation, and I have expressed it in interval notation. Use the graph to determine the values of each. First of all, we want to know what f of 2 is. F of x, we want to know what f of 2 is, so that's x is 2 right here. So this point right here is the point 2, 1. So we're looking for what the y value is when the x value is 2. When the x value is 2, the y value is 1. We're looking for the domain. How far left? How far right? How far left? And how far right does the graph go? Well, let's see. How far left does this graph go on the x-axis? It goes to negative 5. Our second point has an x value of negative 4. Our third point has an x value of negative 3. Our fourth point has an x value of negative 2. This one is negative 1. X value of 0. X value of 1. X value of 2. And an x value of 3. So the domain would start at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Any x values for which f of x is equal to 3. Now let me erase what I have here so that we can look at it fresh. Any x values for which f of x is equal to 3. In other words, y is equal to 3. So let's find where y is equal to 3. Here's 1 on the y-axis, 2 on the y-axis, and 3 on the y-axis. So we have 2 y values that are equal to 3. This one is the point 0, 3, and this is the point negative 2, 3. So we have 2 x values. We have 0, x is equal to 0, and x is equal to negative 2 that have y values of 3. The range, let me erase again. The range is how low and how high. How low and high does the graph go? How low do these points go on the y-axis? This point has it's 3, 0. So on the y-axis, it goes down to 0. This one is 2, 1. So we have a y value at 1. Actually, we have two of them that have y values at 1. We have two of them that have y values at 2. We have two of them that have y values at 3 and one that has a y value at 4. So how low does it go? It starts down here at 0 and it goes 1, 2, 3, 4. We have y values at 0, 1, 2, 3, and 4. Example 2, we have a new graph. f of 0, f of 0, I didn't make that very neat, f of 0. So we're looking for the y value at x equal to 0. So here's where x is equal to 0, and the y value of that point appears to be 1. We have an x value of 0 and a y value of 1. So f of 0 would equal to 1. The domain, let me erase what I've got here. But for the domain, we want how far left and right does it go. The graph, how far left does it go? It goes all the way to -4, and it includes -4. This is supposed to be a filled in circle. I don't know why that didn't stay filled in. How far right does it go? It goes all the way to +4 on the x-axis. This one has an x value of -4. The y value is 4. This one has an x value of 4, and the y value is -3. But what we're wanting to know is how far left does it go on the x-axis? It goes to -4. How far right does it go? It goes to +4. Those are in square brackets because those points are included. For any x values, find any x values for which f of x is equal to 3. So we want to find the x value where f of x is equal to 3. So here's where it would be. The y value, f of x means y is equal to 3, so the y value is 3, and the x value appears to be about halfway between -1 and -2, -1.5, and the y value is 3. So the x value, x is equal to -1.5. The range, how low does it go? It goes all the way down here to -3. How high does it go? It goes all the way up here to 4. So the range is between -3 and 4. It includes those points because there are those points have filled in circles, and those points are included. This is Jo Karen Hudson. Thank you, and have a wonderful day.